So to make this real, let's take a look at an actual Spark script written in Python that will answer the question, what are the worst movies in the Movie Lens dataset? And we're going to define worst as the lowest average rating. So let's dive in and take a look at a Spark script that I wrote in Python that will answer that question. Now, if you were to think about this in terms of MapReduce, that's very similar to how you would think about things in Spark 1. And that's using the RDD interface. We'll take a look at the Spark 2 way of doing things later on, but for now, let's just use the lower level RDD interface of Spark. So how would you actually tackle this problem from a MapReduce standpoint? Well, if you need to figure out the average of something, you need a total of how many times that thing occurred and the total of that value. So what we need to end up with is the sum of all the ratings for each unique movie ID and the number of times each movie was rated. So you can imagine a world where we're just going to reduce down these tuples of the sums of each rating and the number 1 and boil that down to an average at the end of the day. So that's the approach we're going to take. Let's dive into the code here and see how it all works. So we will run this in a moment, but for now I just want you to kind of understand what's going on here. So you might be new to Python. Basically the way that we import libraries that we need is this syntax here. So we're saying from the PySpark library, that allows us to do Spark stuff within Python, we're going to import SparkConf and SparkContext, which will give us the hooks we need to actually create RDDs and do stuff with them. Let's skip down to the actual main meat of the script here. So like I said, we first need a Spark context to work with to create our initial RDD from, and we're going to do that by creating a SparkConf, a configuration class that just sets the name of the application to something called worst movies. So if we were to look up this job running in our dashboard, it would be under the name worst movies. And there's other things you can do with SparkConf, like set exactly how it gets distributed, what cluster it runs on, and how much memory is allocated to each executor and things like that. But let's keep it simple for now. So given that configuration, we can create our Spark context, and we're going to call that Spark context SC. So we have a variable SC that is our Spark context, the environment that we're running within. Next thing we're going to do here is not really a Spark thing. We're just going to load up a Python dictionary that lets us quickly map movie IDs to movie names. And since I know that's a small amount of data, it will fit in memory, I don't need to create an RDD for that. I'm just going to keep that in a Python dictionary so I can use that while printing out our final results when we're done. So all load movie names does is load up the u.item file in our ML-100K dataset from the local disk. Okay, this is not on our cluster. It's just data that we expect to be deployed alongside with our script. Go through each line of that and create a dictionary that maps movie IDs as integers to the movie names. And that gives us back a dictionary called movie names that we can use later on. But back to Spark. So going back to our Spark context, SC, we're going to call text file on it with a path on HDFS to the u.data file. So this is the actual movie ratings data set, where each row, remember, contains a user ID, a movie ID, a rating, and a timestamp. And it's going to load that from HDFS. So that could be, spread out across our entire cluster, potentially. And we're going to load that into an RDD called lines. So already you're seeing how RDDs abstract away a lot of complexity. I don't have to think about how u.data is actually spread across HDFS and how it deals with failure if one of those nodes goes down. All I care about is I have an RDD object that I've named lines that I can do stuff to in my driver script. Makes life a lot easier. So the first thing we're going to do is actually convert that input data into a structure that looks like this. So we're going to create a new RDD named movie ratings that contains a key value pair, where the key is the movie ID and the value is this tuple of the actual rating value and the number 1. So our strategy again is to sum up all of those ratings and sum up all those ones to get a count of how many times each movie was rated. And from that we can compute our average ratings. So to do that, we've written a function called parse input. Let's take a look at that. All it does is split up the input data and returns back exactly that structure, a key value tuple where the key is the integer cast movie ID, and that's field 1 because we start counting from 0 in Python. And then we extract field 2, which is actually the third field, the actual rating, cast that as a floating point number, and the value 1.0. So we have a key of the movie ID integer, and the value is a tuple containing the actual rating value as a floating point number and the number 1.0. And you can see we've defined that as a function. We just pass in that function name to our map function, and that will apply that function to every input line of the lines RDD and output a new RDD called movie ratings. So at this point, we have a new RDD called movie ratings that contains this structure, movie ID, rating, and the number 1. Okay. Next thing we're going to do is reduce that by key. So we're going to sum up all of the ratings and all of those number 1s using this lambda function. So instead of actually defining another function like we did with parse input, we're just going to make that inline using the lambda syntax here. Now when you do a reduce operation on an RDD, you get passed in 2 values. So what happens is that for each unique key, you're going to be passed in a pair of values that need to be combined together in some way. Your function here that you pass in to reduce by key is responsible for combining 2 values together for a given key. And we're saying the way we're going to combine them is to add up both that rating and that number 1 by extracting field 0 and field 1 from both the first value and the second value and reducing that down to the sum as we go along. So once we're done with that operation, what we end up with is a new RDD called rating, totals, and count that contains each unique movie ID, the grand total of the ratings for that movie, and the grand total of how many times that movie was rated. Next thing we can do is convert that to actual averages. So now we're going to do a map to just transform all of those sum and total tuples into an average. And that's all this does here. It takes each value of the ratings, total, and count and transforms it using this lambda function by just dividing the sum of ratings by the total ratings to get back an average. So now we have an average ratings RDD that contains each unique movie ID and their average rating. Okay, so this is a lot to wrap your head around if you're new to this stuff or if you're new to Python. So feel free to hit pause right now and just stare at that for a little while. Let it sink in. And if you look at this long enough, I think it will make sense. Okay, so if you need to take some time, this is a good point to actually stop and kind of like study these last 3 lines of code in particular to understand the flow of how that's all happening. Okay, so at this point, we have the values that we need. We have a map of, we have an RDD that contains movie IDs and the average rating. All we have to do now is sort the results and print them out. So we're going to call sort by, and that basically says, okay, what value do I want to sort by? And we pass in a function that says, okay, I want to extract the second field, which is the average rating. Remember, we start counting from 0, so 1 is actually the second field in Python. So that says I'm going to take the average rating, sort it by that second field, the average rating. So now I have a new RDD called sorted movies that is sorted in ascending order by the average rating. So the top of that should be our worst movies. I can just call take 10 to take the top 10 worst movies. And at this point, I have a Python list called results that I can just iterate through and print out. So this is the point where we go from RDD land to Python land, if you will. So this will actually say collect the final results from the cluster and return them back to my driver script so I can just print them out one at a time. And here, as I'm going, I will use that movie names dictionary that we created earlier to print out the movie name from the movie ID and the average rating. It's just that simple. So let's actually run it, shall we? Now I've already sparked up my little virtual box here, my virtual Hortonworks Hadoop cluster, so that's already running. And what I'm going to do is, first things first, we need to configure Spark the way that we want. So let's open up Ambari. And again, you go to 127.0.0.1:8080 in your browser to get to that once your Hadoop instance is running. And I'm going to sign in with the admin account that we created earlier in the course because I'm going to actually change some configuration in Spark. And here we are. So let's go to the services here, and we'll go to Spark. Okay, and from here we're going to go to configs. So what we need to do here is change the log level of Spark. By default, it's very verbose, and it's hard to see your results when you're actually running the script as a result. So we're going to go down here to where it says Spark log4j properties, and see here where it says log4j root category equals info. Double click that and change it to error. Okay, and hit save when you're done. Type in a little note of what you did. Change the log level for Spark to error. And it will save that. But before that takes effect, we need to restart the services. So go ahead and hit this restart button here and say restart all affected, confirm restart all, and it will go off and actually restart the services for Spark to make that configuration change take effect. Shouldn't take too long. Okay, now let's do the same thing for Spark 2 while we're in here, just to get it over with. Same thing, we're going to click on Spark 2, go down to Log4j Properties, change the root category to Error, hit Save, type in a note of what we did, change log level to Error in Spark 2. And again, once that's saved, we need to restart Spark 2 as well. And we'll let that go do its thing too. Okay. While we're in here, let's make sure you have the data you need on HDFS. So let's go up to the Files view here. And go into the user Maria Dev. And make sure you have an ML-100K folder in here that contains u.data and u.item from the Movie Lens dataset that you downloaded earlier in the course. If you need to go ahead and create that at this point, you should have it from earlier lectures, but you can always create new folders and upload data into it from this UI if necessary. But make sure those are in place, okay? So you should have user Maria Dev, ML-100K, u.data, and u.item. All right, so we have everything we need in place on the cluster. Let's go ahead and actually run this bad boy. So I'm going to open up a terminal to my cluster like we've done before. All right, so I need to download both the scripts that I need to run and the data. Remember, our script depended on the u.info file to actually get those movie names, so I need to download that. So take a look at what's in my home directory here. You might already have this, but if not, make dir ml-1, I can't type, 100k, and we'll cd into ml-100k, and I've uploaded a handy-dandy copy of that for you, so if you need to, you can type in wget http://media.sundog-soft.com/hadoop/ml-100k/u.item. Alright, so now I should have a u.item file within my ml-100k folder, and my driver script will actually use that to create that dictionary of movie IDs to movie names. Now I need to get the scripts itself. There's a bunch of scripts associated with this section, so let's go ahead and get them all at once. So again, I've CD'd up. I'm in my Maria Dev home directory here. Okay, should look like something like this at this point. And I'm going to type in wget http://media.sundog-soft.com/hadoop/spark.zip, capital S. And that should come down here. Make sure it's there, and I can unzip that to get my actual scripts here. So the one we're going to run is lowest rated movie spark.py. Make sure it's there. We can do a little less, lowest rated movie spark.py. And see, that is indeed the script that we were looking at earlier. So let's run it. To do that, we're going to use the spark submit command. So when you're running Spark Python scripts, you don't want to just use Python to run it. That won't work. You want to use the spark-submit shell, which basically sets up all of the Spark environment for you and makes sure that it's actually running on your cluster, as opposed to just running in a single process on your local machine here. Now, since we only have one machine here, it doesn't really make a difference, but normally it would. So spark-submit is where we're going to type in lowest rated movie spark.py, just like that. And that will actually run it. So let's see what happens. Ka-ching. And it's chugging away. And there's our results. That didn't take too long. So the worst movies in the Movie Lens dataset are these bad boys, and a lot of them are tied. So I'm thinking, a lot of these movies were probably only watched by one person, and that one person gave it a 1-star rating. So we can do better. We can think a little bit more about what it really means to be a bad movie later on in this section. But for now, there's some stinkers in there for sure. The Bloody Child, Amityville Dollhouse. I've never even heard of most of these, and there's probably a very good reason for that, because they're probably pretty bad movies. So there you have it, Spark in action. And Spark Submit actually can take a bunch of parameters as well. So you can actually pass in command line parameters on Spark Submit to specify which cluster you want to run on, or specific things like how much memory you want to allocate to each executor on your cluster and stuff like that. Usually, though, your cluster will be pre-configured to actually have reasonable default values for you. So unless you're a Hadoop administrator, you usually don't have to think about that too much. That's all you need to do. So there you have it. You actually ran your first Spark script on a real cluster on your little sandbox here and got some real results. So up next, let's talk about another way to do it using the Spark 2 dataset API.